Hi, hello everyone. Welcome to my YouTube channel. This is Mr. Vignesh from Vignesh Tutorials. Today we are going to discuss, or today we are going to study about our M1 subject for engineering students especially. And I hope you enjoyed the last session. We discussed the basics of matrices chapter of Unit 1. In this session we are going to discuss the further about matrices chapter only. So it is M1. I think it's our class 2, right? Or class 3, whatever it is, let's say. Okay, so we are going to discuss about our matrices chapter. Matrices, and in matrices, we are going to discuss about what is a symmetric matrix. Symmetric matrix. And what is skew symmetric matrix. In last class we discussed about unit matrix, square matrix, rectangle matrix, diagonal matrix and triangle matrix, right? Here we are going to discuss about symmetric and skew symmetric. Let's say A is a matrix. If A is a matrix, then if A is equal to A transpose, then that type of matrix, then that A is called as symmetric matrix. That means if you take any of the number, you get the same way. Like let's say I'll give an example. I'll give 1 2 0 and I'll give 2 minus 3 minus 1 and I'll give 0 minus 1 4. If I take A transpose, I'll get again 1 2 0 2 minus 3 minus 1 and 0 minus 1 4. What do you mean by transpose? Column becomes row and row becomes column, right? Here 1 2 0 is there in column. Here I am writing in row. 2 minus 3 minus 1 here and 0 1 4 I am writing here. So it's interchanged, both are equal. This is an example of symmetric matrix. Then what is skew symmetric matrix? Skew symmetric matrix is just same but with a negative symbol. A equal to minus of A transpose. I'll give an example for this also. Then that A is called as skew symmetric matrix. If it is 2 and let's say just wait a minute. Yeah, same example we can take, like if it is 1, if I take here 2 and if I take 0, same numbers I'll take, but my A transpose this is similar example of this one only, but I want to get minus A transpose, right? To get my minus A transpose, everything should become minus, right? For getting everything minus, this becomes minus, this become plus, this become minus, and these also become minus, right? So instead of making this one, I'll make this one as 0. So here also 0. This minus, this is plus, this is minus. Okay. And what about this one? These two I'll make minus 1 minus 1. Or let's say if it is 0 and 0, let's say. Okay. Everything is 0. Like if it is a scalar matrix, generally you will get a, yes, now you can see here same matrix I have manipulated. If it is a scalar matrix, in general, not every scalar matrix, not like every skew symmetric matrix you cannot tell it's definitely a scalar. It may be or may not be, but if it is like a scalar matrix, definitely your A transpose and negation of it will be is equal to A. So this is the example for skew symmetric matrix. Please take a screenshot of it And if you have any kind of doubts, ask in the comment section. Okay. Now our next topic is Hermitian matrix. Hermitian matrix. A is equal to A bar of whole transpose. You know what is transpose? Transpose implies column and row interchanges, but A bar implies complex conjugate. The sign will be changing. Like for example, in A, if you have 2 3i, 2 minus 3i, and minus I, 0 4i plus 3. It is a 2 rows 3 column matrix, and if I get a bar, I will be like having my 2 and minus 3i and 2 plus 3i and 1 0 4 minus 3i. Only my conjugate part is going to change the sign. Please observe here, only my conjugate part is going to change the sign in taking a bar, that is complex conjugate. Now taking transpose of that one, if I take transpose of that one, then it will become, if I take transpose 2 minus 3i and 2 plus 3i, then 1 0 4 minus 3i. This becomes the transpose. If these two are equal, actually in this example those are not equal, just to tell what is A bar and how it is going to change into A transpose. You can check whether the matrix A is Hermitian or not. You can check like this. This is not a Hermitian matrix because these two are not equal. No, these two are not equal. So if they are equal, it is a Hermitian matrix. Okay. Check some any kind of example. I'll give you one example. I'll give you a proper example here for Hermitian matrix. Okay, let's take A is equal to 4 1 plus 3i and 1 minus 3i and 7. Let's take A bar is equal to, so you will get 4 1 minus 3i and 1 plus 3i and 7. Generally for square matrix only this is possible, and A bar of transpose you get 4 1 minus 3i 1 plus 3i and 7. So these two are same. So this is the example for A is equal to A bar whole transpose. This is the example for Hermitian matrix. Now let's check what is skew Hermitian matrix. Now let's check what is skew Hermitian matrix. Skew Hermitian matrix. Okay. Here in this same thing, but here A is equal to A bar transpose, it will become minus. So with a negation symbol, same thing. Example will be like of course similar, but this is the definition for skew Hermitian matrix. If you have any kind of doubt, please ask me now itself. I hope you are clear with this. So with this topic I am closing this session, a very minimal session. In the next class we are going to discuss about how to find rank of a matrix and echelon form and normal form. We are going to discuss these in our next sessions, okay, in upcoming sessions. So please keep watching my videos, follow my channel. It is Mr. Vignesh Tutorials. For further doubts, please mention your doubts in your comment box and I'll be assisting you. Okay, like, share and comment. Follow my channel, subscribe and press bell icon for further updates. Signing off, bye bye.